Hi everyone! Today's notes are on proportions, which might seem like a review, because it is, because we've already learned proportions. So hopefully though you'll see these proportions this time in a new light, and how it's related to unit rates in this chapter. So let's begin. A proportion is an equation stating that two ratios or rates are equivalent. Ratios or rates, and of course those are really just fractions basically. So we're trying to say that two fractions are equal to each other, such as something easy like 2/3 equals 4/6. How do I know that? I could explain by saying, well, to get from one numerator to the next, I would multiply by 2. And the same is true for the denominator, multiply both by 2. You can pause and write that in your own words. Alternatively, you could also say that 4/6, when you reduce it, equals 2/3. That is also true. So, hopefully you remember cross products. If you do, then this will be a piece of cake. The cross products of any proportion are equal. Circle the top left numerator and the bottom right denominator, and then circle the bottom left denominator and the top right numerator. If you multiply these two pairs of numbers together, you should get the same product. So cross meaning we're going across diagonally. Product, we're multiplying these together. Now we're not really solving anything here, we're just proving that these are equivalent, that they're equal. If I multiply 12 times 15, I would get, figure it out. I'll race you. 180, and I like to put that answer at the top left here. If I multiply 36 times 5, I'll find out it also equals 180. This is just one way to prove that they are equal. Sometimes we do this to check our answers. This one's easier to see. 8 times 3 is 24. 6 times 4 is also 24. Those are equal. And 16 times 7 and 8 times 14. You try it. Moving on. This is useful cross products when we're missing one number. Proportions are equations. So when we have to cross multiply, we continue to write the result as an equation. So you probably remember me reminding you when we learned this earlier, not to drop the equal sign. So let's try it. We do 2 times y, multiplying across, is going to be equal to 34 times 5. Just what we did before. These were equal, but now we're going to write it out. 2 times y equals 34 times 5. As a reminder, it doesn't matter if it's y times 2 or 5 times 34. That part doesn't matter. Step 1, you could write some, this is the only time we're going to write some notes. Multiply diagonally and set equal to each other. Step 2, simplify what we've got here. That means 2 times y, I can get rid of that multiplication sign. And 34 times 5 happens to equal 170. Do you remember before, anytime we have an equation, our goal is to isolate the variable, the y, and I want to get rid of the 2. I have to follow some rules. Whatever I do to one side of the equation, I have to do to the other. And to get rid of a term or number, I do the opposite operation. So this is 2 times y. I'm going to isolate the y, isolate the variable, by, in this case, dividing by 2. Whatever I do to one side, I do to the other. And this will equal 85. And I've solved that by cross products. Not so bad. Now, you don't always have to do cross products, but it's the method that always works for solving proportions. Sometimes in this next example, it can be easier. You can just see by doing some mental math how to get the answer. You would ask yourself, how do I get from 3 to 21? It must be by either multiplying or dividing. This would be multiplying by 7, so you do the same here. So n must equal 49. And you should ask yourself, does that sound reasonable? Well, compare the first ratio, 7 over 3. So one way you could say is, well, 7's more than double what 3 is. So my numerator answer should be more than double what 21 is, which would be 42. And that's a little bit more relatively. Yep, seems reasonable. That's one way to check. You can also do your cross products and multiply, and those should be equal. Why don't you try the next one, doing cross products? I'll start you off, but you're going to have a multiple choice answer that you need to show me when you come to class, and we'll do our plickers again. But I'll start you off here. So 1.5 times g equals 3 times 10. Step 1. Step 2, simplify. And step 3, I'm going to get rid of 1.5 times g by doing the opposite by dividing. And whatever I do to one side, I do to the other. So take a moment, pause the video, and be prepared to tell me which of these is the answer when you come to class. Record that on your paper. Let's do one more of these. The next one, actually I lied, we're going to do both of them. X times 10 equals 4 times 9. Keep that equal sign. Don't skip steps. There's not really that much to show. Simplify. 10x equals 36. You'll notice we keep doing the same steps over and over. I want to get rid of 10 by dividing, because anything divided by itself equals 1. Oh, I'm going to stop you there. You tell me the answer. Here are your choices. And the last one right now we will skip because we have more on the back. Turn to the back when you're ready. Okay, so here's where you might start noticing how this ties in with what we've been doing so far this chapter. Another way to solve proportions is to use unit rates, to write an equation. And we just did equations with direct variation. That's what we're going to do again as well. For example, Olivia bought 6 containers of yogurt for $7.68. One way to do this. Number 1, start by finding the price of each yogurt, or the unit rate. Over and over, we keep seeing that when we have unit rates that involve money, we put the money in the numerator, because I want to know how much money per yogurt. So right now, $7.68 per 6 yogurts. And of course, I'm just dividing. I didn't give myself a lot of room here. Make sure to put your decimal point in the right place. I'll continue my work over here. Oh, and this goes in evenly. How nice. I don't have to do any rounding. So my unit rate is $1.28 per yogurt. Remember, that means it has a denominator of 1 yogurt. Step 2, what can we do with that? Next, write an equation that expresses the relationship of the price you pay for the number of yogurts you buy. Let's use C for cost and N for number of yogurts. So let's start with what we've done so far. Knowing that we have a unit rate, no matter how many yogurts we buy, the price is going to be the same. That means this is proportional, which means we can write the equation in direct variation. Y equals Kx. Remember that K is our constant of proportionality. X and Y always represent the ordered pairs we would use when we were graphing. So starting with X and Y, all we have to do is take our unit rate, which is our K, and plug it in. So Y equals 1.28x. Now let's use what it says in the equation. It says, well, let's use C for cost and N for number of yogurts. So the X represents the number of yogurts, because we're saying $1.28 times the number of yogurts would equal the cost, which would be our Y or our C. So this is going to be C. The cost is $1.28 per yogurt. Whenever you say per, in this case, we are multiplying by the number of yogurts. So that is still technically in direct variation, even though I changed the variables. Continuing, you can use this equation to solve for any number of yogurts bought to find the cost. So this applies to any amount of yogurt she buys. If Olivia bought 11 yogurts, what was the cost? So I'm going to rewrite the formula. The number that she bought in this case was 11, so I'm going to substitute safely using parentheses, but we're just really multiplying. And multiply this out. What's it going to become? Make sure that in your answer you have 2 digits behind the decimal point. And I got 1408. will be her total cost for 11 yogurts. Sounds reasonable. Always check for reasonableness. All right, we're going to have a few more problems, and I'm going to have some more questions for you to answer. Back when I was on Team Columbia, I worked with Mr. Fierro. So, Mr. Fierro likes Smarties. He ate 7 Smarties in 2 minutes. Write an equation relating the number of minutes to the number of Smarties eaten. How many Smarties would be eaten in 9 minutes at this same rate? So let's break it down bit by bit, starting with finding the unit rate. Ask yourself, are we going to be finding Smarties per minute or minutes per Smarties? I hope you chose the first option. How many Smarties per minute? Remember, with the unit rate and with any rates, you have 2 different units. Otherwise, it's a ratio. Again, as we keep doing, we're just dividing. 7 divided by 2 is 3.5 or 3.5 Smarties per minute that he's eating. Let's use this information now to write an equation. And this says consider which is your input and which is your output. So this might help you when you're replacing our x and our y with our other variables, m and s. But it's always y equals kx. As you've seen in class, the constant of proportionality is the same thing as the unit rate. All I have to do is find that number. That's how it all ties in. So y is 3.5x. And we've got minutes is m and Smarties is s. So he eats 3.5 Smarties per minute. If I plug in number of minutes here, is that going to tell me how many Smarties he ate total? Yes, it is. X is always input and Y is always output. So I think about, what am I really trying to find out? I'm trying to find out how many he's going to eat total. So this is S for Smarties and M for minutes. 3.5 times the number of minutes will tell me how many he ate total. So refer back to what we did in this last problem and complete number 3 right here. Pause the video so you can figure out how many would he eat in 9 minutes. And here are your choices to choose from. Replay the video when you're ready for the next question. Mrs. Davis is an avid reader. She can read 12 pages in 8 minutes. Write an equation relating the number of minutes to the number of pages read, P. How many pages could she read in 15 minutes? So this is the same setup as before. To begin, find the unit rate. We want to know how many pages per minute she can read. 12 pages over 8 minutes. I notice that I can just reduce this, divide them both by 4 to 3 over 2. But I'm talking about pages per minute, so I think I'm going to change this to a decimal. 1.5 or 1.5 pages per minute. Makes more sense. There's my unit rate. The next 2 are up to you. So in part 2, write an equation. Here's your 4th question and its answers. How would you write that equation? And the last one, number 5. Once you know that equation, plug in the value 15 and which answer is appropriate. I have one more thing to tell you. Please ask your parents tonight and be prepared to tell us or have the information ready when you come to class next time. Find out how much you weighed and how long you were at birth, because we're going to use that information in class. For example, I was 7 pounds 6 ounces and was 21 inches long. So if you're not sure for yourself, find out from your parents. See you soon.